Good day. My name is Elizabeth Holmes and I will be moderating today's webinar on data citation. Just to give you a bit of a background before this presentation, earlier this year we announced our participation in the Data Citation Implementation Pilot and our commitment to implementing proper data citation for our journals. Since February, we have made enormous progress and are proud that we recently made data citation available. With this webinar, we hope that you can learn more about the principles and practice of data citation. We welcome two presenters today. Dr. Timothy Clark, who started the Data Citation Implementation Pilot for Force 11, will explain the Joint Declaration of Data Citation Principles, why data citation is important, and how data can be made citable. Tim will be followed by a presentation given by Dr. Helena Hussain, co-chair of the Publisher Early Adopters Group, who will explain how you can start citing data today. There will be time for questions after the presentations, actually during the presentations, because you can just type in your questions. However, there will also be more time later on, and I would like to encourage you to join our Mendeley Data Citation Group, where Timothy Clark and Helena Hussain and other experts in the field will be happy to answer your questions and discuss the future of data citation. I will mention the link at the end of the presentations and send the link to you over the next couple of days. Let's begin with a 15 to 20-minute presentation by Tim Clark, followed by a 10-minute presentation by Helena Hussain. As you probably read in the invite, Tim is a researcher in biomedical informatics and computer science in Boston. It gives me great pleasure, Tim, to hand over to you.
Thank you, Elizabeth. This is going to be a short talk about what is an emerging practice and a very important practice for reproducibility and reuse of scientific findings, particularly, I would say, in biomedicine. I'm going to walk you through sort of the foundations of this practice in theory, what we're doing about it in practice, and how it actually benefits both science as a whole and you. So, NIH, the National Academy of Sciences in the U.S., and other science policymakers, not just in the U.S., but for example, the Royal Society in Great Britain and comparable institutions in the Netherlands and so forth, have been very concerned over the recent period about scientific reproducibility and robustness of results. You may have heard these reflected in discussions about false positives in the literature, increasing rates of article retractions, big data and data reuse, and so forth. And a number of significant science policy studies over the past, say, 5 years or so have recommended that primary data that forms the foundation of any published scientific findings be archived in a robust way and cited directly in the article. NIH is now running something called their Big Data to Knowledge program, or BD2K. And the goal of Big Data to Knowledge explicitly is to facilitate broad use of biomedical digital assets, that they should be discoverable, accessible, and citable. Another way of saying this, by the way, and this was started by this whole discussion of these principles was actually started by people in the Netherlands, the acronym FAIR, findable, accessible, interoperable, reusable, applied to data sets. So there are technologies and many recommendations now in place about doing this, and there's even a significant NIH-funded program to construct kind of a PubMed for data, But in order to discover data and reuse it, you need to be able to find it. And to find it, it has to be there in the first place. It can't just be on your thumb drive or in your laboratory website. It has to be someplace that's somewhat persistent and reliable to access. In the same way that publishers like Elsevier and Nature and so forth make their publications available on websites that persist over time. So why should we archive and cite data? Well, these are the kind of big picture reasons. One is for better science. We want to promote transparency and validation. If you publish a finding and you say, here's a graph that I've generated off my data set and it supports this interpretation and this finding, that's all well and good, but it would be very nice to know, see the primary data that you actually used to generate that graph, and to, in fact, to know in clear detail the algorithms that you used. That's always been part of the scientific method, but with the growth and size of data sets, they can no longer fit in little tables in the publication. So another reason to do it is for reuse and discovery. Aggregating data sets, putting them together for big data meta-analysis, and to extract new knowledge. In our work here at the Massachusetts General Hospital, we were involved in a major program of finding new targets, therapeutic targets for Alzheimer's disease, and we use open data sets extensively in this. The last reason, big picture reason, is to radically improve biomedical translation. You have to have reproducibility and robustness of findings in order to translate them over to industrial drug development. And ultimately, that's how we develop therapeutic agents to cure diseases. So let me give you some more reasons to cite data that are more focused on you. The first one is it's just plain good scientific practice. Data has been foundational as a criterion of truth in science since the scientific revolution, when we changed over from just having arguments and discussions about conclusions from the ancient classical literature to actually finding and developing findings on the basis of data sets. You want to be good at your job, right? So you should do it. Another question that comes up is, and you could call this the future you versus the present you. In the future, you're going to want to reuse your own data, and archiving it in central repositories is a great way to back it up and make sure it's accessible. Making it accessible, citing it and making it accessible to others also makes it accessible to you in the future. We've built data archives here in the Harvard community at the Stem Cell Institute, and when we first started this practice, people asked us why they should put their data sets in there, and we give them arguments to convince them that it was a good idea. And they sort of said, oh, okay, we'll do that. And then about a year after we built this archive, people started coming to us and saying, oh, you know that data set that I put in there, is there any way I could get that? Because my postdoc had that data and now he's gone. So future you versus present you. Want to provide for future you. And the last reason, and this is very important, is funders spend a lot of money to enable you to get that data, and now they're thinking of it as a resource that they don't want to lose. They don't want it to go away. So NIH and other funders will require it. So how did we get into this business of data citation from these studies going into practice? And there was an intermediate step called the Joint Declaration. And this was a meeting or a series of meetings hosted by our nonprofit organization Force 11, and brought together people from the National Academy of Sciences, European agencies, and so forth, to work through, to kind of harmonize the recommendations of all these studies and boil them down to a few principles. And you can see them here. And without going into them in depth, I'll just say the number one thing is that data are legitimate, citable projects of research. They are the foundational evidence in science, so you have to cite data where an assertion relies upon it. And then there are technical aspects about unique identification, access, persistence, and so forth that are important to support point 6, which is facilitating access to and verification of data. And the last of these, interoperability and flexibility to accommodate different communities. Now, let's go into citing data versus citing literature, because I think some people can get a little confused. I've heard the question, well, if I cite data, then I'm not citing literature. So if I'm citing my data sets, I'm not citing my papers, and that's going to reduce my impact factor and so forth. Actually, it doesn't work like that. So there are sort of 3 use cases or situations that we're going to talk about. First is you should archive and cite your own primary data sets when it's primary data on which you base claims in your article. It's similar to the idea that's very common, especially in, say, molecular biology papers, where you have an image or a chart and you say, you make a statement and you say, see figure 3A. When, for example, figure 3A is your image data or stats plot. Only in this case, you're pointing to an external reference, right? So cite your data when you base a finding on it, and it's your data, right? It's your primary data. When should you cite someone else's data versus citing their literature? You cite someone else's previously archived data sets when you use them as data inputs to your computational analysis. So you're doing a meta-analysis. You're reanalyzing data sets from Sage Synapse or GEO or some other data repository. Only when you use them as actual data input to your analysis. Right? And lastly, the sort of long-standing existing practice of citing existing literature remains as it does, and it has still very important. You cite the existing literature as you normally do when you're citing someone else's claim, finding, or assertion. Right? Now I'm going to talk about another step. After the development of these principles, a lot of discussion went on about how do we move from having these things as abstract principles that lots of people agreed on. In fact, over 100 scholarly organizations endorsed them, including many publishers and funders, to something that could actually be applied in practice. And this is where the data citation implementation pilot came in. It was organized through the Force 11 Consortium and was funded as part of NIH's Data Discovery Index project. And the goals of this pilot really were to get the early adopters together, essentially, and to make sure that they agreed as community participants in exactly what the implementations, the technical implementation details would be and how they would affect their say, publishing workflows, author instructions, the metadata on the repository landing pages, and so forth. Right? And Elsevier has played an important part in this and is continuing to do so. I must say, Helena Kassain co-chairs our publisher early adopter group in this pilot. We have a lot of participants actually, though, and that's really important. We're trying to make sure that the early adopters get on the same page and that technically everybody's taking the same approach so that software agents and people have a consistent experience across the network. So all of these logos, and this is what I call the mandatory logo fest in many talks, right? All of these groups and many others have joined this pilot and participated and contributed to it. And we hope to have additional work going beyond this in the future and extending it to many more publishers. But I think we have really quite a few of the major ones here. Now, what does a data citation look like? Well, it's not so peculiar, actually. It's really very similar to a literature citation. It consists, and this little diagram maps some of the characteristics of a data citation to the principles that we discussed earlier. So you have the authors, you have the year, the data set title. Instead of a journal name, you have the name of the repository or archive in which it's deposited. Could be GEO, could be European Nucleotide Archive, could be Dryad, could be Zenodo, could be a number of these repositories. You have then also a global persistent identifier. What does that really boil down to? It boils down to a DOI or a URL. And actually, in fact, it boils down to a URL because DOIs, which you're probably quite familiar with, only really resolve when they have the proper prefix, like http://doi.org/ and then the DOI. Then it becomes a URL that you can resolve on the web. So this is very recognizable, and the only really different things here is that we have at the very tail end we have, well, first of all, the persistent identifier is required, and the version or subset, because it's data set, is also required. So what does this look like at a sort of top level? So on the left, we have the document citing the data. So you have a citation that ties the assertion in the paper to a reference in the reference list. And there's, as I said before, there's a persistent unique identifier that takes you to a landing page in the repository. The landing page describes the data and then allows you to get the data. So it's actually very straightforward. So the components of all of this are really, that make it happen, are the publishers, the repositories, you, the authors, and the informaticians. And we're hoping to bring all of these together, and I think we're doing it. We had, in this project, we had an international executive from many different institutions. And as I mentioned, we had a publishers expert group headed by data-related people or data management people from Elsevier and Springer Nature. They've done a tremendous job. So we have a publisher's roadmap that's really going to be published in the peer-reviewed literature early next year. As Elizabeth said, Elsevier announced that they've implemented the specifications that they helped co-develop with many others through our initiative in 1,800 journals. I believe from discussions that I've had that Springer Nature and other publishers are not terribly far behind. So you'll see this start to be widely implemented. So this is just a little discussion of what the publisher's roadmap approach is. I'm sort of running behind, so I'm going to skip ahead. We also had an expert group put together from data repository experts to kind of coalesce how you would see data sets represented on the landing page of a repository and what machine-readable metadata would be available to software agents, and et cetera. Drill way down to the sort of geek level here, but it's very important. And it's a little snap that we took at San Diego at our last workshop. And their roadmap is near complete as well. So the key thing here about landing page metadata is that it makes the data set information available to software to construct these data discovery indexes which are, as I mentioned, like PubMed for data. So lastly, I guess I want to say that we need to systematically archive and cite data to improve the scientific transparency, reproducibility, and robustness of the literature. The literature is our lifeblood, but there are a lot of problems in the literature, and we now have both the incentive and the means to fix them. So persistent discoverable archives will enhance our capability to validate and reuse data. And the goal here, at least in the biomedical realm, and I think this actually applies to other realms as well, is to significantly improve the ability to translate research findings into either new findings in other areas, and continued advancement of the science, or translation into practices that benefit the broad population. So with that, I'd like to conclude and hand this back to the moderator.
Thank you, Tim, for this very thorough explanation. It gives me great pleasure now to hand over to you, Helena Kusain. Helena is a Senior Product Manager for Research Data at Elsevier. Helena obtained her PhD in neuroscience from the University of Oxford, where she developed a strong interest in research data. Having worked with various kinds of data, which all presented their own challenges, Helena now has the chance to develop solutions as Senior Product Manager for Research Data at Elsevier. Over to you, Helena. Thank you.
Thanks, Elizabeth. In this part of the webinar, I'd like to provide some practical information and talk you to some of the steps you need to take if you want to start citing your data. So as Tim already mentioned, one of the first questions that may come up is, when do you actually cite data? Now, I would say if you've used research data in your research, then data citation is always relevant. If you've acquired the data yourself, you might want to provide a consistent and persistent link to the data through a data citation. Or also, if you've used or reused existing data, you might want to increase transparency by citing the data set and also credit the original creator that way. As with other citations, I would say that the main principle is that you cite everything you used. Now, one of the prerequisites to be able to cite data is that the data is actually available. So if you've acquired the data yourself, you might want to look for a relevant data repository for your data. Many publishers maintain lists of supported or recommended data repositories. And on the screen, you can see the list of supported data repositories that Elsevier maintains, also with a link at the bottom should you want to have a look. Here you only see a couple of domains listed, but would you scroll down, you would see many domains. So you can go through a list and see if there's a relevant domain-specific repository within your discipline where you can deposit your data. Now, should that not be the case, then there are also several general data repositories that accept data in all file formats and from all different disciplines. And here I've used Mendeley Data as an example to show you how you can generate your data citation. So what I've done here is that I've uploaded some files, I've given my data set a title, provided a short description, and Tim already talked a bit about persistent identifiers, and if you look on the right-hand side, you can see that a DOI has been reserved, and that's now the unique identifier for my data set. And that's actually very important because this is uniquely associated with my data set, so always provides a way to identify and find my data set. And underneath that DOI, you can see how this data set could be cited. So I can now use that myself, or other people can use it as well. So this includes several components, including, again, also the DOI. So now we've actually deposited the data and generated a citation. Now, if you want to start preparing your manuscript for publication, you will probably have a look at the guide for authors of the journal you want to submit to. Now, as was mentioned, we've implemented data citation. So for most of the journals, you can go to the guide for authors, and if you look at the references section, you can find a text describing how data citation works and what data references should look like. What you can also find underneath that is a specific example of what a data reference looks like. And this is also formatted according to the reference style of the journal to make it very easy for you to put your data reference together. And here you can see the different components of the data reference, so the authors, the year, the title, which are of course things that are also present in an article reference, but then also the data repository, the version, and the persistent identifier, also in this case a DOI. Something else I think is important to mention is that at the beginning of the example here, you can see dataset between brackets. It's important to add that so that we can actually recognize that this is a data reference. So our systems will recognize it and process it correctly. So if you put this in, we will know that this was a citation to a data set. Now, we just generated the data citation for the data set that I uploaded. So if I would now want to prepare a manuscript that was based on that, I would simply cite this in the text. So in the same way as you would also do when you cite an article. And people reading the text would then know, oh, see, the data are actually available for this article. And then in the reference list, I would format the reference in the way we just discussed, starting with data set and then have the different elements for a data reference. And the order and exact formatting will depend on the reference style, but the example that you see in the guide for authors will provide you with guidance around that. So for example, does the year appear following the authors, or does the year appear following the repository? That can differ based on the style that the journal uses. So far we've seen how you can put the citation and the reference in the manuscript, but how does it now actually appear in the published article? Well, you can see an example here from an article that was actually published. And what you can see here is that it appears in a normal reference list together with other references, and that it actually looks quite similar. So it's formatted in the same way. Something important to note is that we now have the DOI here, and this the unique identifier, and this now actually forms a link. So in this way, both reviewers and readers have very easy access to the data underlying the paper because they can simply click this link in the reference list. You might also notice that the dataset between brackets is no longer present here within the article, but it is actually still present in the underlying structure of the article. There's a tag that indicates which of these references is a reference to the dataset. And because it's present in the underlying structure, it's possible to pull this out and start counting how many citations there are to datasets. And this is of course very important because that way people can start receiving credit. And I think that's actually one of the main principles. If data are shared and are made available and then data are cited in the reference list, people have very easy access to the data. More people are aware of the data, which increases data reuse, which is not only good for science, but also then generates more citations. So you have more data sets cited in the reference list. And because we're able to count those, we can actually start giving people credit for the data and the work they did on that. And data can become part of the reward system. Thanks a lot, and I'll hand back over to our moderator.
Thank you very much, Helena. I have a few questions that have come through from attendees, and I will read them out. And perhaps one of you, Helena or Tim, could answer them. The first question has come in from Gilon Harfan, and it says, surely we cannot rely on a URL for persistent identifier, since there is no guarantee of persistence.
So I'd be happy to answer that. So I agree and disagree with the question. So it's true that sort of let's say a naked URL we can't rely on for persistence. However, what we're proposing be done is to go through resolver systems, right? So DOI will be a persistent identifier, and it has to be to actually resolve it on the web. Though you have to put it in URL format, and maybe that I wasn't quite clear on that. So DOI is a system that does provide persistence to identifiers long term, and there are other less well-known systems similar to DOIs that will also work, but you must format this as an HTTP URL. Okay, that's all we're saying.
All right, thank you very much. We have our second question, and that is, global persistent identifier means DOI, or is the DOI just one example of such a global identifier? If so, what other identifiers are there?
Yeah, maybe I think Tim already partly answered this question, but maybe to make it even more explicit. So the DOI is probably the most well-known type of global persistent identifier, but there are some other examples, and I think in particular some of the biomedical repositories have other kinds of global persistent identifiers. But normally when you deposit your data in a repository, you will be assigned one of these global persistent identifiers, which is then associated with your data set and can be used in citations.
Thank you, Helena.
Right. I'll just add that it sort of varies by domain, and if you go into, for example, the museum world, they have something called ARCs, ARKs, which are also, they sort of follow the same principles as DOIs, and they use them to identify artifacts in the museums and so forth. But I think DOIs are sort of the best known, as Helena said, and the ones that we're kind of focused on here.
Thank you. Next question. How do we obtain a DOI for the data set?
Maybe that wasn't clear enough, but in many cases when you deposit your data in a data repository, they will assign the DOI. So the main thing is to actually find an appropriate repository for your data, and there you'll be able to get your unique persistent identifier or your DOI. So Tim, I don't know whether you want to add something to that?
Yes. I would say all of the general purpose repositories and some of the specialist biomedical repositories will provide you a DOI when you deposit the data. Now, people are probably pretty familiar as well with the notion of accession numbers. If you deposit in a specialist biomedical repository, that's just a lot of sort of common practice. And if you're interacting with the journal editors, I think you can provide them an accession number if the DOI isn't provided. Helena, you can correct me, but I believe that you can do that. And if you there are resolvers for accession numbers now as well. So, for example, identifiers.org at the European Biomedical Informatics Institute. So if you simply provide either the DOI or the accession number back to the journal editors, I think that will be good enough, and they'll add the resolver prefix to that so it can resolve globally.
Okay, thank you. What about intermediate steps between the observation, in brackets primary data, and the final graphs or figures? Would you save that for the SI, or should that be a cited data set too?
I assume that SI here refers to supplementary materials with an article.
It could do.
So yeah, Tim, do you want to start?
Well, maybe it's worthwhile to suggest the question, what is primary data, right? And how many intermediate steps do we want to track? And I think that's kind of a judgment call, right? And I guess I would say that you provide, where you have something that you're convinced is a stable observation, right? And then all you need to do is run it through an algorithm to get your final results. I think that's the primary data set. I mean, you could in a lot of these repositories put in the general purpose repositories. You could put in lots of intermediate steps, and they will support that. I think that in a general purpose repository, that's up to you. In the specialist repositories, for example, Geo, just go with what they ask for, and that'll be your primary data set.
Yeah, so maybe to ask this from the publisher perspective, we've always found that what's seen as the most shareable data really depends on the discipline. So it's very difficult to say it's always raw data that should be shared, because that's just not always true for all disciplines. And we generally say that the best place for research data is in a data repository, because there it's also independently discoverable and citable. So we do like to encourage researchers to deposit their data in a data repository and cite it in their article.
Helena, I really like your notion of the most shareable form, and I think that's really helpful.
Okay, let's go on to the next question. What about intermediate steps? Oh, sorry, we've already had that one. Does data citation work the same for all disciplines?
I think that maybe in this webinar we focused a bit more on biomedical sciences, but in principle, yes, what we discussed applies to all disciplines, and we've also implemented this in the same way for all the different journals. So yeah, from my perspective, this is relevant for all fields of science.
All right, I have another question here. Can you please comment on data ownership? Once the data is deposited in data repositories. Can you comment?
I think one thing that hasn't really come up is maybe the concept of licensing, because very often when you deposit your data in a repository, you'll have the opportunity to select an end-user license, and with that license you can communicate how you want the data to be reused. So you can, for example, say people can reuse the data, but then I want them to cite my data set and provide proper attribution. So in that way you can still regulate what's done with your data set. So Tim, maybe you have something to add to that?
Well, I guess again from sort of the biomedical research, so I think you focused on the key point, which is licensing, right? The data is your intellectual product, no question, and under the law, it's your intellectual property or that of your institution, depending on what your relationship with the institution is. So licensing does become the key factor here, and in the case of biomedical data, many times this is it's mandated by say the NIH or the BBSRC, et cetera, to go into specific repositories that will have their own sort of licensing rules, and you have no choice about that. If you took the money, you have to follow those rules. However, if that's not the case, right, and especially in these general purpose data repositories, I think Helena is absolutely right, and you can choose, and these are kind of subject to your choice. You get a menu of options.
Great, thank you very much. I think that's all the questions we'll take for the time being. But there is just one comment in the list of questions I have here, and that is that this has been a great webinar, and congratulations to both of you. So thank you very much, Tim and Helena, for your excellent presentations today and for eloquently answering our attendees' questions. Thanks to everyone who registered to attend this very exciting event. And should you have more questions, please use the Mendeley community link that you see on your screen now, and that we will send over to you in the next couple of days via Twitter or email. Thank you very much, and I hope you have a wonderful day. Bye-bye.